Hey everybody, I'm Ben. Um, as is almost mandatory when doing slide presentations, you have to put your job title and where you work. So I am currently a software engineer in the ML department at Databricks. You may have heard of us. We're a little company out of San Francisco that offers this cool data platform that allows you to do all sorts of stuff with managed open source software that a lot of it we build, stuff like Delta, ML Flow, and something that a few people may have heard of, Apache Spark. Um, so the team I'm on is the open source ML Flow team, which is a very misleading title. We handle pretty much all of the open source ML integrations that we have. So if you are on our platform using, of course, ML Flow, we're, the maintainer group. And if you interface with stuff like PyTorch or TensorFlow or XGBoost, most recently Ray, we do a lot of those integrations and make sure that they work well for everybody. So, intro again. I'm Ben. I've done a lot of weird things over my career, and some of that may have come out in the text that you guys may have read in the book, um, and some of the examples that I use throughout the book. Not exactly the latest and greatest, hottest stuff that everybody's talking about, and that was intentional. As I was doing everything, I wanted to pick the old school, somewhat seemingly boring stuff and kind of show that it's really useful because that a lot of that stuff is used in a lot of industries. And I've worked in a number of industries, not just in the software space. But the most important thing about my career is I've done a lot of stupid things, like tremendously stupid things. I've checked in code that wasn't even checked in. I've had stuff running in production that the only copy of the code is sitting on a desktop computer or on a laptop. I've built models that I could not reproduce, that I could not explain. Um, I've built stuff in a vacuum to try to solve problems for somebody without even talking to them and tried to ship it and then found out that I built the wrong thing. So all these stupid things that I've done. And like bridges I burned when trying to help people out in companies many, over a decade ago. I learned a lot from those, a lot of self-reflection, sometimes external reflection from people saying, "What are you doing?" Um, and just try to process all of that and learn from those mistakes. That transitioned into a role change about 6, 7 years ago that I was helping people by imparting the wisdom of my stupidity and follies. And then somebody just suggested that I write a book. Actually suggested to a publisher that I write a book on this topic. They reached out to me and said, "Hey, people think you should write this because, you know, they seem to think you know a lot about this stuff." I was like, "No, I don't. I'm an idiot. Um, but I've done a lot of dumb things and I can write about that." And they're like, "Yeah, do that." So what I do now, as I mentioned before, software engineer in an ML department. I'm an ML Flow maintainer, which is a silly title. Basically means you're an admin of an open source project, and you control what gets merged and what the priorities are for that project. Uh, I'm a team of about 6 people that are globally distributed around the world. They're all awesome. They're brilliant. And it's really cool to be able to do stuff like dial into, you know, main stage things for big companies presenting something at a symposium and then seeing like, oh man, they're demoing or they're using something that I built. That's super cool. So it's an interesting side effect of my job now. Something else I do every Friday, record a podcast about machine learning. Sometimes it's not about machine learning. Sometimes it's about process. Sometimes it's about just stuff that's adjacent to data science work or analytics. Check it out. It's everywhere. The people that manage the podcast, they spam it out to everywhere you can listen to podcasts. But we have some really cool people, really cool guests. Uh, Not always people that are just data scientists or ML people. We talk to really fascinating humans about really cool topics. So as I was saying before, I had a really weird career background that everybody I talk to that asks me about this is always fascinated. Um, but here it is laid out. 1997, straight out of high school, joined the U.S. Navy. Did that for 10 and a half years, and then get got out of the Navy. And I did a bunch of different things in the Navy, which were also, kind of interesting. Everything from operating nuclear reactors to repairing kitchen equipment on an aircraft carrier to driving tugboats. Super weird. After that, I went and got a job doing something completely removed from anything I'd done before, which was work on the R and in the R&D team at a massive factory up near Scranton, Pennsylvania. Uh, I had no ties to that location. It was just a job, and I found it interesting. They're like, "We're trying to make this thing called Blu-ray a thing." So think about how long this has been out. That's how long ago this was. So we were basically building the process where you could fit a 4 hour long movie on a single disc. And the manufacturing for that is somewhat complex. And I was working with teams that were building the machines that make the discs. After that, I had my fill of that. Um, Went down to around Raleigh, North Carolina, a company called Cree, working as the worst acronym in the world, but it's Metal Organic Chemical Vapor Deposition Engineer. And what that is you grow LEDs on silicon carbide substrates in a process that takes about 5.5 to 7 hours in a reactor that gets very, very hot and flows a bunch of super toxic gases over a substrate and actually grows a crystal lattice on top of a wafer. And you control temperature, gas flows, pressures, all sorts of crazy stuff. It's the most complex recipe that I've ever had to work with in my career. And yeah, you write it in an Excel spreadsheet. It's mind blowing. But that was pretty cool. Did that. Saw the massive emergence of blue light LEDs, which everybody now is very familiar with because that's the stuff that's in streetlights and in the light bulbs in your home. Uh, the team that I was working on, like we were the ones that invented all of that stuff and made it commercial, so the light bulbs could be made. Learned a lot there, and then got really tired of that and got called by a tiny little company out of Austin, Texas, that has this tiny little factory in the north of the city called Samsung Austin Semiconductor. I'm being facetious. It's the second largest factory in North America. Um, and that's where they made iPhone chips, the system on a chip brain behind iPhones. So we are doing iPhone 2, 3, and 4 at the time. When I came in, it was 45 nanometer. When I left, they were doing 15 nanometer. No, 14 nanometer was the last tech tree that I did. So yield analysis engineer is a really dumb job title for what is now called a data scientist. And you just analyze terabytes of data and trying to find signals for what is causing you to not make as much money in the factory. Uh, and that company and that factory in particular, uh, they're basically making Scrooge McDuck money. It's insane how much money comes into a semiconductor fab. But super cool, tons of data. I learned a lot while doing that and had my fill of that. Went to go work in a B2B company doing like model building. Um, Probably the worst job I've ever had. But yeah, modeling like estimations of revenue and employee headcount at every physical address that a company operates on the planet. Super weird project. Uh, really had my fill of that left uh, to basically be the first data scientist at a fashion company. Like there's a theme here that there is no theme of moving from one thing to another. Uh, but I thought it would be interesting to start an entire data science team, and they had this massive initiative with the new CTO. They're like, "Hey, we need the first person to prove out that we can do this at this company." this guy seems like he's done some cool stuff. Let's get him in here, and then we'll give him a budget to hire a bunch of people. And did that, learned a lot about doing large scale ML, um, and got my first exposure to using Apache Spark for something other than ETL, using Spark ML and some of the algorithms. And that was when I got exposure to Databricks and uh, built some really cool projects with some really interesting people, uh, made that company an obscene amount of money. And towards the end of my time there, Databricks actually contacted me and said, "Hey, we have this position. It's a field representative. You go and help other companies that are trying to do what you self-taught yourself and your team to do on our platform. Are you interested?" And I said, "Sure, that sounds cool. I love your product." So I did that for about 3.5 years at Databricks, working in the field. So it's post-sales, where you interact with, it could be 4 or 5 companies a week, teams ranging from one person to hundreds of people. Lots of on-site stuff that you work on projects. You write a lot of code for people. You build solutions and advise people. So I learned a lot doing that, um, just interfacing with all these different teams. And midway through my time doing that was when Manning approached me and said, "Hey, we've heard some things about you. Would you like to write this book on all the advice that you're giving people?" I was like, "Sure, let's do it." Uh, Fast forward about a year after that, I started working unofficially with the ML Flow team at Databricks for about a year and a half. And then they said, "Hey, do you just want to transfer over and become a software engineer?" I said, "Yeah, let's do it." And I've been there doing this since. So things that I've learned that informed what we're here to talk about, the book and some of the examples that I use and the messages that I have. Uh, no matter what industry that you talk with or that you're in, there's this supposition that data is data and everybody sees it the same way and everybody uses the same way, and nothing could be further from the truth. Uh, Everything is very, very different. People see problems and utilize data and collection methodologies and the types of models that people build and what they're looking to get out of with respect to inference or predictions or trend monitoring, whatever it may be, outlier detection. They're all different, and getting exposed to enough of them shapes this way of thinking about this profession and how to generalize, you know, approaches to problems. And that kind of has shaped how I approach things in an interesting way. I'm not saying it's the best way, but it's unique, I guess. Another big thing I learned, it's okay to screw up, and as long as you fix your mistakes and learn from them. And it's always best to share with others. When you make a mistake uh, and you correct it, document that, record it, tell other people about it, share your pain so that it doesn't have to be other people's pain. And the big thing that prompted me, not just Manning approaching me about writing this book, but the thing that made me want to write it, is because of just the sheer volume of stupid things that I've done and the terrible coding practices I've had. The If you can name something about the process of pushing a data science backed or ML backed solution to production and think of the worst possible thing that you could do to make that be unmaintainable or just super painful to have to deal with in production, I've done it and learned the hard way, usually. Because a lot of the places that I went to, I was the first one that was doing this. And I was so far out in left field with regards to other people at the company that knew better, like software engineers. They're just like, "Yeah, we don't really get what you're doing, and we're really busy. We don't really want to, help you out with this. This is your thing." Uh, I just had to go through it the hard way. And then working with a lot of customers for Databricks in the field over the years, I started to recognize patterns in things that they were doing that I had learned were bad years ago, and it sort of just made me feel like there's not a lot of content out there in either blog form or YouTube video form or books that talk about the things that people aren't really interested in generally. Everybody wants to learn how the algorithms work, and they want to learn like, oh, I want to see code examples of how to leverage this new deep learning technology, and I want to know how neural nets work. Or there's a lot of the technical aspects that have been written about and are talked about, and there's blogs about using software packages for applied ML, but there wasn't a lot of stuff that I had heard of about people saying, how do I actually get something into production? And how, as a data scientist, do I learn how to work with other people? And what is most important about a project? Spoiler alert, it's not the model. It never is. That's the easy part. The other stuff is hard. And I figured since I'm talking about this to so many people day in, day out for years, why not just write a book about it and maybe some other people could get some use out of it. So, it's kind of why I wrote it. And closing remark on that, the dog in the book is real. He's downstairs right now, and he is always hungry. So there you go. There's a couple of slides.
Wow, thank you so much. That was very impressive. Your journey from engineer to data science to sales and then back to engineer. Wow, how did you manage doing all that transition? And what's your advice for people who are in similar positions trying to figure out if they want to be a data scientist or if they are a data scientist trying to become a software engineer? I think people often want to explore different career options, but the transition could be really hard.
I'm gonna have probably the worst advice for anybody here for this. Uh, and to put it in perspective, getting into the organization that I'm in right now, um, it has like, very stringent hiring practices about becoming a software engineer at Databricks. It's really hard. It's considered in that ecosystem of FANG companies. It's not part of the acronym, but it's on the same level. Uh, am I smart enough to have walked in the door to get hired off of interviews for that? Probably not. I probably wouldn't have made that through there. I don't have a CS background. I have a degree in nuclear engineering. It has nothing to do with computer science. Um, and then if we go back even further to other jobs that I've landed, like yield analysis at Samsung, I was probably the least educated, dumbest person that came in there as part of that department. Yeah, I was working, the vast majority of people that I worked with had PhDs in material science and chemistry and physics. And I'm like, yeah, I understand what you guys studied, kind of. Can I understand the theory behind why it is that this oxide layer is 4 nanometers too thin and about barrier, leakage for electrons between a gate and a junction, emitter base leakage or something. Like, no, I didn't study that. Um, but for everything that I've tried to do, I follow the advice that a guy in the Navy told me when I was 19 years old. And when I was trying to get into doing something that was sort of a voluntary, working group uh, in the field that I was in. And you had to prove yourself in a series of interviews and kind of show that, you had what it takes. Uh, and I remember I was telling him, I was like, I don't know if I'm gonna, be good enough to get into this. And uh, I don't know if this is gonna work out. And he just sort of hand on the shoulder and he's like, what are you talking about, man? He's like, let me tell you something about life. and about working life and about how things work. He's like, anything that you want to try. He's like, don't ever be your worst enemy. And he's like, if you're worried that somebody's going to tell you that you're not good enough, like, don't ever worry about that. He's like, just make them tell you no. I was like, make them tell you no. He's like, go for it. Just don't sit there and ask permission to do something that you want to do and that is good for, an organization or a company or, you know, your family or a team or whatever it may be. Just go and do it. And then if somebody tells you, stop doing this, we don't want you to do this, then just say, okay, all right, I'll stop. I've never had somebody tell me that. In anything that I've come into companies and moved into different departments or into different positions. It's happened to me many times over my career. And that whole make them tell you no philosophy is how I've moved from place to place and shifted, you know, different jobs within a company that have changed the trajectory of my career until I found something that was like, I actually enjoy this. This is super cool. This is really hard and I feel dumb every day, which is an awesome feeling. Um, so yeah, that's my advice for people that want to transition. Um, that doesn't mean ignore them when they tell you no. That means just make them tell you no. And if they don't tell you no, that means you got carte blanche to continue doing something, provided that it's adding value.
Love it. I just love the advice. Just do it. But sometimes you have priorities, and managers may saying like that's not a priority. I guess how do you deal with that?
And that's honesty. If you're absolutely honest with a manager and not trying to say what you think that they want to hear, um, be like, well, I know that this is a priority for the team, and I don't want to, make it. I don't want my manager to think poorly of me, and with me saying that I want to do something else. Uh, if you're walking on eggshells and tiptoeing around an issue with somebody it's their job to make sure that you're going to stay with the company. It's the purpose of management. If you fundamentally break it down, there's the only job of a manager is to keep employees. Because otherwise, if you're good, another company's going to offer, wave a whole lot more money and a whole lot more freedom at you, and you'll just bail. So a manager's job is to make employees happy and successful so that they can make the company money or, increase productivity or something. So the more honest you are with your manager, the easier it is for the manager to do that job, that core job. Like, hey, yeah, my team has these responsibilities, but your team is any good manager knows your team is really not going to hit those deadlines if your employees start quitting. And how long does it take to train up somebody new to replace this person? If they're really good, it could take a year, 2 years, 3 years, depending on the complexity of what you're doing. So if you're honest with a manager and say, hey, I really have a passion for this thing and I want to do this thing. I want to explore this at this company, either under your management or working with this other team or something. If they're good and they actually care about, their employees, uh, they'll usually let you try that out or have a conversation with whoever is in charge of that part of the company to let you prove yourself. Um, if they're terrible and they say, no, I can't support that, it's time to find another job. That means that person doesn't care about you as an employee or as a human being. Find another company to work for. There are great managers out there. Don't suffer through, you know, idiocy like that.
Yeah, 100%. Appreciate the insights. Um, yeah, I mean, come back to the book. Which chapter do you like the most? Also, like for book club members, feel free to ask questions whenever, or ask questions like directly in the chat or type in the chat, however you like.
This is going to sound terrible, but I can't even remember what chapters have what in them. Um, so the process of writing a book means that you read that text so much over, it's a good year and a half of your life that is working a second job, basically. And you end up rewriting, like I think chapter one was rewritten 37 times, um, like completely rewritten from scratch 37 times. Um, chapter 12 might have been rewritten twice. And the reason that is because you're adapting as you go along and you're like, oh, yeah, first three chapters, they're not really working anymore with the tone of the rest of the book. We need to change that. Sometimes it's the author doing that. Sometimes it's the editor being like, dude, this is terrible. Sometimes it's feedback from early reviewers. So you read it so many times that when you're done with it and you get that big, well, I think there's like four big boxes somewhere in my office that haven't been opened. One of them has been opened. This is just each of them has like 40 copies of the book. I've never opened it. Um, the only time I've ever touched them or opened them is to sign copies for people. Um, I think, but the themes that I really like were that I enjoyed writing about was about working with others in cross-functional teams. That is probably the biggest lesson learned that I've had and that I've passed on to multiple teams at both big and small companies. Um, the process that I would always use when talking about a new data science project. Everybody's interested in like, oh, what models can we use and what hyperparameters should we tune? I'm like, like this is the first 10 minutes of the meeting. This doesn't matter. We don't like it doesn't we don't need to talk about this. And then people would get obstinate and kind of pissed off with me. And I'm like, listen, can I talk to the subject matter expert? Like, who knows about this part of the business? This isn't a data science project for the data science team. If that was the case, all we need is the data science team. Um, but most data science organizations aren't building stuff for themselves. I was like, who in the business cares about this the most? If it goes really, really well, who cares about it? Who's gonna who's gonna want to take credit for this if it goes really well? Or if it goes really bad, who's going to be most angry at you that this is going to go south? They're like, well, marketing team or sales or, you know, the the inventory specialist, they really care. I'm like, all right, let's take a 30-minute break. And when we come back into this room, let's have a couple of them in the room with us and let's break down what we're trying to solve. That process, I long ago lost track of how many times it happened where we walked out of what was probably going to be or was scheduled to be 3 weeks worth of daily meetings on site. Uh, and we end up leaving at the end of the first day, realizing that this problem can be solved with a simple SQL query, and just getting data to the people who need it in a consumable form so that they can make informed decisions. You don't need a model to do this. Like the human mind can do this looking at a chart and make more effective decisions than any predictive modeling can. And that's a win. And letting the data science team know that, like, hey, you just dodged a bullet. You provided a valuable service to your internal customer. They're going to be happy. You don't have to maintain some huge code base that is probably not going to work that well in the first place. And you can go and work on something else that's more interesting, and that's the goal, like solve problems. That was the most fun to write about. I don't think I wrote enough about it though. And certainly in the years since, while working more as not so much in the applied engineering space anymore, and now in the pure software engineering space, there's there's probably an entire another book that I would want to write about what it's like thinking through how to design and develop those things and making sure that your customers are in the room as well.
Awesome. We have two questions coming from the chat. Um, would you like to take a look and see which one you like to answer or any thoughts?
A couple of questions about the technologies that you've been working on at Databricks. So you mentioned that you're working on technologies like Apache Spark. I am not. Um, we, our team supports Spark ML, but not stuff like Spark Core. There is a lot of brilliant engineers at Databricks and in the open source community that deal with Spark. It's a big ecosystem. Um, and then the question goes on to say, which is just a micro batch processing technology that's mainly used for feature engineering on streaming features. Not exactly. It does a lot of stuff. Um, Structure streaming is one thing. That's definitely what you mentioned. Uh, but large scale batch data processing, yeah, that is another thing. But Spark ML has a lot of stuff to it, a lot of it not very well documented. Um, and the big data nature of it is such that you can solve problems of scale that are very, very challenging to handle in any other sort of modeling technology. So you take something like uh, frequent pattern growth, the F-growth algorithm in Spark. If you have a corpus of purchase data, um, 50 million customers, over 100 million products, which 100 million SKUs, that's a lot, but some online retailers have data volumes like that. Uh, how do you get fine-grained recommendations for something of that nature in a raw format for a model, which you can then do post-processing on, where your raw output of a model like that could be terabytes of data. You can't do that with sklearn, XGBoost. It's just you can't really. Most people aren't willing to pay that amount of money to run like a torch model of that complexity and dealing with data volumes of that size. It becomes just economies of scale. Spark becomes cheaper. Uh, Other part of that question, I also know that Spark has built-in solutions through Spark ML. It does, but this is extremely limited to the online applications that it tries to implement. To implement powerful models, we need to use more powerful machine learning frameworks. I don't know if I buy into the powerful machine learning frameworks. Something really fun about that I learned in the last 10 years about a lot of these algorithms. When you go down to the library level optimizers, when you start thinking about like, well, how does something like, sklearn, it's linear models, what is the solver? And you look at it, you're like LBFGS, like what the heck is that? Like I know what the algorithm is, but where is it implemented in code? It's calling this Python module um, that's compiled somewhere, or it's referring to some other external library. When you go and look at the source code of that, and you're like, hang on a second, this is Python that's wrapping, you know, some other code. Well, what is that code? What is this library that it's using? And you get down and you look and you're like, hang on, this is Fortran? And you look at the comments at the top of the Fortran code and you realize that it was written in 1982 and it hasn't been updated since. Uh, you look at some other applications that are out there in the Python community, people are like, oh my God, this new package. And you look at low level enough with some of these implementations, they're calling Haskell code, they're calling Fortran, they're calling these optimized implementations that are super fast computationally. The math hasn't changed. The APIs may be easier to use. They look cooler. The framework that they run on might scale out differently. You can do parallelization, you can do multi-threading, multi-processing in a much more easier way. But at the end of the day, the algorithms are the algorithms. There's not a lot of advancement that happens in those, except when you're talking about new architectures and applications of certain things. You look at like where did, you know, RNNs go to LSTMs, then go to transformers architecture, and then 5, 6 years later, after that advent of that, it's all of a sudden explodes, and now your grandmother starts talking about it at the Thanksgiving dinner table about ChatGPT. Well, all of this stuff built upon itself, but at its core level, those solvers that were being used in the implementation of these transformers models in Torch or in TensorFlow, most of them are in Torch. They're still using that same Fortran code. Um, I wouldn't get too, wedded to performance aspects of certain libraries. It's more about the APIs and how good of a fit they are to your use case, and how clean can your code be, implementing wise when you're using that stuff. I don't know. There's kind of a soapbox answer to half of that question. The other half, Flink started to support a Python API like Torch and NumPy, which leads me to believe that an ML applications can have a combination of feature engineering and model store. I mean, that's what Databricks does. It's kind of their bread and butter. ETL, feature engineering, ML, within Databricks, using stuff like, integrated hyperparameter tuning, using PyArrow, which we can scale to ludicrous levels of data sizes with that. You know, a lot of cloud providers are also providing solutions like this. It's less about the tech. It's more about, because everybody's using similar tech. Um, it's more about how good of an experience you can give your users. How easy is it to use your platform? How easy is it to learn your platform? And more importantly, how well do you support your users? Are you building the features that they're asking for, that they need? Are you being responsive to when things don't go well? And are you listening to their feedback? And the providers that do all of that and the platforms, even the open source communities that do all of that, they're the ones that see massive uptick in user base. And then the second question that I have is in general with continual learning and modern ML. Obviously, most modern continual learning solutions deal with data iteration, where we just refresh the data the application is trained on. However, due to modern research on paper number one, paper number two, do you think in the near future we'll be seeing continual learning through efficient model iteration? Maybe. I don't think it's going to be that sort of solution is going to be applied in high risk environments. So you think about some of the things that models are deployed right now, um, to automate away. It's not about replacing humans. It's about scaling humans. So we have models that are out there that are trying to detect leaks in oil and gas pipelines that spread throughout the North America right now. Um, those Some of them are pretty sophisticated vision classifiers. They're looking at slices of video feed data on cameras that are posted throughout pipelines, and they're trying to detect an environmental catastrophe early enough so that something can be done about it before it becomes something that you create a Superfund site, uh, and you know absolutely obliterate the environment and animals that live around that. So if you're in a continuous training environment where all of a sudden your feedback loop of raw data coming in and labeled data goes awry because of some sort of classification error or some bug in code, and that model is continuously retraining, and there's no negative reinforcement loop. So you can have like reinforcement learning. That's definitely a thing. We have tons of people doing that on Databricks platform. We interface with people using Ray to do that on Databricks. Um, cool systems. Nobody does anything that's super critical with things like that because of um, the potential for training drift to happen. And if that occurs in our scenario here with the oil and gas pipeline, all of a sudden the model doesn't learn to detect a leak. So we're not getting any more false positives. We're getting a bunch of, false negatives. Uh, and we're completely just missing all of the true positives. When this sort of classification error happens, we now have an environmental catastrophe. Um, Other models that are deployed for financial systems, nothing that really matters um, at extremely high trade volumes is done with any open source ML toolkit that you can think of. It's all custom algorithms that are being maintained by a team of quants, and they know exactly what's going on. They don't make changes without, testing it extensively. Uh, usually in sort of a shadow deployment for a long time before they're like, okay, let's flip the switch on this and see if we lose, $500 million in 10 minutes. Um, but there's other, off the shelf sort of open source algorithms that are out there that people are employing for things that you might be surprised about. Uh, the more serious of the application that it's being used for, the more rigor that goes into it. So when you conduct training, you're really evaluating on holdout validation data and simulating a bunch of stuff because depending on what it interfaces with or what decisions it's making and how people trust it, uh, a company could go from profitable to not profitable in a matter of days or weeks, or you could ruin the livelihood of an entire industry of people, depending on how severe it is. So I don't think the online stuff is going to become used for the stuff that people really are interested with applied ML, not anytime in the future.
We have some questions coming from the Discord server. Some people are curious about generative AI because every company is trying to implement generative AI in their systems, no matter why and if they actually need it or not. So, curious about your thoughts on um, the implications of using generative AI in some of the machine learning systems and the challenges of making uh, productionize generative AI applications versus traditional machine learning models.
An excellent question. And I'm at an interesting point in my career and what I do right now to provide a highly biased and probably not objective answer to any of this. A lot of the stuff that my team has been working on over the last, year almost is stuff around Gen AI. With ML Flow, we built all this new stuff to support usage of these, to allow people to build whatever they can build, interface with these APIs, interface with these large models. A lot of the stuff that I worked on earlier in the year was making it so you could build your own, take a pre-trained model from Hugging Face Hub using Transformers library and, fine tune that model and then use ML Flow to keep track of that fine tuning and to log it and deploy it. Some of the more interesting use cases that we're seeing recently is not just using an LLM. By themselves, they don't really do all that much that's really interesting. When you look at the applied ML, layperson interface with these, what do people think of when they think about Gen AI? They think of Chat GPT. They think of a chatbot that you can ask it questions and it gives you, when we were talking about GPT-4 and the latest retraining that they did last month, it's pretty darn good. I'd say upwards of 90% accuracy for most questions that you can throw at it. And it's very good, provided that you understand how to engineer your prompts properly and tell it what you expect it to do. It's awesome. Um, but how do you build a product out of that? That is a product. That is a user-facing product. You're not gonna build your own version of GPT-4. Sorry to tell everybody out there. You need the resources and not just the humans at OpenAI. You need the money at OpenAI. These things cost an exorbitant amount of money to train. They require a lot of data cleansing and labeling um, in order to, and that's not labeling actual pieces of text. It's going through and using traditional NLP of doing crazy stuff like, can I remove profanity from all of these examples of text that I'm going to use for training? Can I remove sarcasm and idioms? And can I equate, you know, these words like using synonyms in the appropriate way and making sure that I have a distribution of synonyms that occur naturally within this language's body of corpus. Lots of work, lots of complexity, lots of money. So best not to try to compete with that. But what you can do is take something that's like a pretty good open source, you know, a lot of stuff that Mosaic has put out is really great. A lot of stuff that Meta has put out is awesome. Take one of those, train it on a corpus of text that you want it to be really familiar with, and initiate fine tuning, and then deploy that yourself and use it to answer questions about your product documentation or, you know, something about your sales brochures so that you can now have an interface where it understands the nuances of language and can convert that into an embedding vector that you can then use to retrieve information from. So you can build like a RAG system, retrieval augmented generation. Those are going to be the next new big hotness. A lot of people are building them right now. We're helping people build them at Databricks. And that's where you start seeing real value come out of this, where you can expose a chatbot that chatbot has no idea about your internal data at your company. But with a RAG model where the chatbot is basically generating a query that you can query your actual data with, and it has access to embeddings information, and you can ask plain text questions about what is the current inventory of 2017 Nissans that are either white, blue, or gray. You know, that query, um, with all the additional information about it, you start putting in like a price range that you're willing to buy. Um, if you were to create a UX for that on a website, how many clicks is that? 20, 30? How many like failed query attempts are you doing? Forward, back, forward, back, forward, back. It's just a terrible experience. That's what we've all been dealing with internet search for bespoke, you know, discrete data sets for the last, 25 years. And now all of a sudden these RAG models are coming in that you can just type in a general question, type a small paragraph, and then you get your top five sorted results of probably what you're exactly looking for, or things that are very similar to that. That sort of application is going to take off, and the people that are building those successfully with their own data, they're going to eat their competitors for lunch because the process of being a customer to that company, you just simplified it to such a degree that nobody has to be annoyed with your UX anymore, or they get what they want as fast as they possibly can get it. Those are the things that data scientists, I think, should be thinking about. How do we build these things? Because they're cool, yeah, but because it's going to allow our company to be very successful, and I'm going to get a promotion and I'm going to get paid more money, or I'm going to get to talk about this at a conference. Whatever your motivation is, it's going to be good for your team and your crew at your company. But the traditional ML, probably not a very popular opinion, but I do not think this is going away anytime soon. Uh, I know everybody wants to talk about the latest and greatest hype. Uh, I remember 6, 7, 8 years ago, I was sitting in meetings with people where people were trying to convince me that so long as we use this LSTM to solve this time series modeling problem, we're going to make so much money. And then me saying, all right, let's do a bake-off. We take 72 hours. You build that solution and then show me the code. And then I'll build something with stats models. And we'll see, how long they take to run, how easy the code is to maintain, and what the performance is. The traditional old school modeling techniques won out every single time because it's not about the technology that you're using. It's how well can you solve that problem at the lowest cost. And that's cost of money, hardware, human cost. How complex is this thing that we're building? How hard is it to fix when it breaks? And so long as those problems still exist, which they always will exist, you're always going to have people who are seeking out solving problems in the simplest way possible, which I am a huge supporter of. So if you can solve something with a very simple set of linear equations, why would you use deep learning? If you can get 98.9% accuracy on holdout validation with a simple regressor, not even like linear regression, just a simple regressor, and that solves your problem, write the code, test it, put it into production, and then revisit it in 5 or 6 years because you have to update some libraries. But it's just going to run. It's going to be automated. It's never going to change. You'll have to retrain something, adjust some weights or something, but it's so simple and easy to maintain. Whereas, yeah, to deploy that torch model that it takes 4 hours to retrain every week, and the total cost of ownership of that in time and resources and money, you know, 50, 60, $70,000 a year versus something that costs $5 a year, you know, things to think about.
We are running out of time, but I guess we can have one last question. You mentioned you're working on Gen AI on ML Flow for a year now. I'm just curious about if you can share about the progress, all the feature, um, and any sort of thing like that.
The progress has been exciting. It's so cool seeing everybody use the stuff that we're building. And we always sort of geek out, which is different than how it would happen in a data science environment. It's less about the tech. Like we're not interested in what we're interfacing with or what sorts of cool things do we get to use in Python or are we going to get to use this library? We're very much averse to that. I think that's pretty common for most software engineering groups that maintain open source projects is to keep it as simple as possible. But we get interested in the use cases that people could be using this for, and we get to talk to tons of different people who both, users in open source as well as, Databricks users who are going to be using this parts of ML Flow that we're building, and just hearing their excitement and how this is going to revolutionize this particular really challenging problem for them. It's super cool. And you get to build the thing that people get to use. And then you find out later what they used it for. And you're just like, man, that's cool. There's just stuff that is being worked on now with like RAG, um, where you can interface with the data set and have, embedding retrieval so that you get the answer instead of having to figure out how to write tons of SQL query code in order to get some answer. Or even worse, you have a corpus of documents like PDF documents or something that just it's just this volume of text that even if you have a very sophisticated search algorithm that's on top of that, it's not semantic search. It doesn't understand the context of what it is that you're actually asking. But these generative AI algorithms and even the open source stuff, check out sentence transformers, SBERT. It's awesome. Semantic, you know, contextual search. You can do things with that model where the embeddings that come out of that encoding process understand the nuance. They don't understand, but they get mapped to a trained data set that has some sort of pattern associated with the nuance of language. So it can focus its attention uh, basically on the aspects of what you're asking such that it can more accurately match the embeddings that you're looking for. So you can ask some pretty complex stuff and it will retrieve things that you're like, that's as good as a human would do if they were like asking a librarian, hey, can you find me 10 books that like best encapsulate this theory of what I'm trying to search for at the library? A librarian will go out 3 or 4 hours later, they'll find 50 books that are probably the best in the entire library, and then they'll give you the top 10. These Gen AI systems with RAG that are basically doing that same exact thing, you get those results in less than a second. So it's awesome. So it's just cool. Like getting a chance to work with this stuff.
Awesome. I am super excited about Gen AI as well. Uh, yeah, we're out of time. Thank you so much, Ben, for spending time chatting with us. Super
Sure.
grateful to have you today.
Thanks for having me. This was fun.
And thank you, everyone, for joining us. See you guys next time. Bye.